Hello everyone, my name is Revati and today I would like to say about some of the searching algorithms that are present. Okay, let me start with the algorithms. Mainly, searching algorithms are of three types. First one, linear search. And second one, binary search. Third one, this is the bit different one, but most of the times we use it because the time complexity will be there less as compared to the previous ones. That is hashing. These three are the mainly used algorithms for searching. So what is searching? Means if we have a particular array and we want to find a particular element whether that is present in an array or not. So in that cases we use these searching algorithms to find that element. Okay, let's consider an example first. By considering the following array and also we'll try to take the target element. Target equals to let's say target equals to 9. So this means we have to find the target element whether it is present in an array or not. So now we have to traverse throughout the array and find the target whether it is there in the array or not. So we use different kind of techniques for finding the target element in an array. So firstly, coming to the linear search. The linear search is mainly applied on the unsorted arrays, and the linear search time complexity will be also very high compared to the other ones. So the procedure that's happened within this is the iteration is going on throughout the array, means until the element is being found, the iteration will process will be going on, and the time complexity will be order of n, because if the element is found at the last position, we have to traverse until the last position. So that is the reason we consider the worst cases in most of as a developers. So I start from 1, that means at the 0th index, and continues till n minus 1 if it is a worst case. And if the element found at the first position, it is considered to be as the best case. And if it is found at the middle case, so it is considered to be as the average case. And this linear search algorithm took the time complexity order of n and also works on the unsorted arrays. And if we write the pseudocode for this, array, let's say that's an array that we have considered, and we have to iterate towards that loop. As I am familiar with the Python programming, I am using Python programming syntax for writing the pseudocodes. Based on the logic, we can convert according to the syntaxes of different languages. And if in the pseudocode that I have written, the I value is being iterated towards the array, and it's searching for the target. If array of I, when it matches the target element, then it is returning the index of that array, target element. So if the element is not found, then it returns the -1. And the next one, binary search. Taking the same array, the binary search is nothing but dividing an array into parts, and based on the target value we have given, we'll move either the left side or the right side. But the only thing we have to remember while using the binary search is we have to use only on the sorted arrays. So if we consider an array of sorted array, this is the sorted array that we have used. So if the target element that we have taken, target equals, for suppose let's say it's a 7. If we take the 7 as a target element, then we have to first calculate the mid value of this array. How can we calculate the mid value? Means considering the lower bound and the upper bound, we can calculate the mid value, and we can say mid equals to lower This is the formula that we use to calculate the mid value, but this may works on that may be flexible to work on the shortest length arrays. If we want to work on the arrays that has the more length, so that then in that cases we can use this formula. Lower bound plus upper bound by the operation is being the same in both the cases, but when we are dealing with the small arrays, we can use this formula, a lower bound plus upper bound by 2. Or else, if we are dealing with the larger size arrays, then we'll go with the formula lower bound plus upper bound minus lower bound by 2, because this reduces the uh, calculation time for the compilers. So in such cases, we use this formula. And when we calculate the mid value, the array based on the mid value will compare the target value. When the target value matches the mid value, then we'll stop that iteration. If the target value is greater than that mid value, then we'll move towards the right. Or else if the target value is lesser than the mid value, then we'll move towards the left side. This is all happened in the binary search. And if we consider the time complexity of binary search, it's a big O of n. Sorry, big O of log n. Because we are not comparing each and every element to find the target element, because we are using a sorted array, means we'll know which our target element which side will be there. Based on that mid value, we are moving either the left side or the right side, so half of the elements will not be taken into consideration. So that's the reason why we are taking only the complexity as order of log n. So the time complexity will be better than the linear search. But the only drawback that we observed in the binary search is we should only apply binary search for the sorted arrays only. And the last one, hashing. Hashing means This is a very efficient one, which is the mostly used one, and the time complexity will also be in the constants order of 1, because if we consider an array that may be sorted or unsorted. If we consider this array, then we'll map the values. That means we'll take a hash map or the dictionary to map the values and search the elements one by one. In such cases, the dictionary or the hash maps will take only the time complexity of order of 1. So the hashing will be more efficient and as compared to the linear search and binary search according to the time complexity. And this is all about the theoretical information about the searching. Thank you.